So hello guys, welcome to the video. So in this video, we'll solve the question about Pascal's triangle 2. Alright, so first let's read the question and then we will try to solve it. So the question is, we are given an integer row index. Alright, so we have to return the row index row of the Pascal's triangle. Alright, so we are given an integer r, let's say r. So we have to return that rth row from the Pascal's triangle. Alright, and inside the Pascal triangle, each number is the sum of two numbers directly above, or it is also a pattern which can be made from a combination max. Alright, so we will understand what is Pascal's triangle, and for more clearance, watch video till explanation. Alright, so you are watching video only, so yeah, I will make you clear everything. So the Pascal triangle is created like this. So yeah, this is a Pascal triangle in which, as written in the question, let me write first clearly. 3, 3, 1, 1, 4, 6, 4, 1. Alright, so yeah, so what, as written in the question only, that the sum of these two numbers is this number, the sum of these two numbers is this number, the sum of these two numbers is this number, the sum of these two numbers is this number, the sum of these two numbers is this number, and the sum of these two numbers is this number. So as given in the question, we can say this is also approach to get the solution of this question, because we have to first create a Pascal's triangle and then we have to return the rth row. That means if it says that we have to return 0, 2, 3, 4. So let's say if it says that we have to return fourth row of this Pascal triangle, so we have to return answer 1, 4, 6, 4, 1. So this should be our answer. All right. So I hope you understood this, how we can approach this solution, and can we create our solution by using this? Yes, because we have already solved Pascal's triangle in our patterns level 1, and we can do the simple calculation that if these two numbers are added, it gives a new number, which is the number in the next line, in the next row, or we can do anything. All right, so at last we will find this solution, but this solution is not optimized, so we will not use this solution. We can go for another solution. So I will go for another solution and I'll write this Pascal triangle in some other method. So let's say if 0C0 is 1, if 0 not 0, 1C0 and 1C1 is 1, 1, 2C0, 2C1, 2C2 is 1, 2, 1, 3C0, 3C1, 3C2, 3C3 is 1, 3, 3, 1, 4C0, 4C1, 4C2, 4C3 and 4C4 is 1, 4, 6, 4, 1. Alright, so can I write this Pascal triangle like this, and when we solve the values of these numbers, we will get this Pascal triangle only. Alright, so how we will get it? There are some properties or some basic formulas for Pascal triangle. Let me write here only. One is NC0 is always 1 and NCN is always 1. So these two formulas are very simple and you have to remember this, because in this question we can use these two formulas a lot. Alright, and there is one more formula where, let's say, NC1 is N. Alright, so these three formulas will be used a lot in this question. So I will take this and let me just make it small. And I don't know why. Alright, so yeah, I will shift it here. And I know these formulas, so let me see if these formulas work on this question. So yes, NC0 is 1. So NC0, that means 0C0, and N can be 0. So if it is 1, alright, I'll write 1 here. Now NCN is 1. So NCN like means 1C1. 1C1 is 1. Alright. And NC0 is also 1. Alright. And all NC0s are 1. So let's say these alls are 1. Alright. These all are 1 because NCN are also 1. Alright. So do we need this kind of pattern? Yes, we needed this kind of pattern only in which first and last index are always 1. Alright. And the mid index, what about the mid index? Let's say NC1. NC1. Alright, so we have NC1 here. NC1 is N. So NC1 is N. That means 2C1 is 2. 3C1 is 3. 4C1 is 4. Alright, so do we have this? So 1, 1, 1, 1, 1, 1, 1, 1, 2, 1. So we have 1, 2, 1. Here we have 1, 3, 3, 1. So we have 1, 3. And we have to find this out and 1. So we have 1, 4, 6, 4, 1. So we have 1, 4 and 1 at the last. We have to find these 3 elements now. Alright. So to find these 3 elements, we have another formula. And the formula is NCR is equals to n factorial upon r factorial into n minus r factorial, which means let's calculate it. So let's say 3C2. So 3 factorial upon 2 factorial upon 3 minus 2 factorial. So what is 3C2? 3 into 2 factorial, 2 factorial into 1 factorial. So 2 factorial is cut it down with 2 factorial and we are left with only 3. So the value for this is 3. Alright. Let me take another example and show it down again to you. Let's say 4C, let's say 4C3 or 4C2 only. Alright. 4C2 is 4 factorial upon 2 factorial upon 2 factorial. So it means 4 factorial into 3 factorial into 2 factorial. 2 factorial into 2 into 1. Alright. So 2 factorial is cut it down with 2 factorial. This 2 is cut it down with 4 and 3 to the 6. So do we have 6 here? Yes, we have 6 here. Do we have 3 here? Yes, we have 3 here. Alright. So I hope you understood this by using this formula. So we'll save this formula here. So now what? We got the formula. We understood this. How can we solve this? But just tell me one thing. That can I do this every time? Like, can I go on every element and see first that if it is 2C1, 2C0 or 2C2, or if it is 1C0, 1C1, alright. So we can't go on every element and see this, or if it is 3C2, let's say, we do not have that much time to calculate every element by n factorial upon r factorial into n minus r factorial, because it is a hectic process. Alright. If in this pattern we have only 5 rows, but if it is given that we are given 1,000 rows, so how we will solve it? Alright. So for that we have to take a optimized approach. Alright. We have to get an optimized approach. We will write it like this only. Let me write it again only. 0C0, 0C1, oh sorry, not 0, 1C0, 1C1, 2C0, 2C1, 2C2, 3C0, 3C1, 3C2, 3C3, 4C0, 4C1, 4C2 and 4C3, and at last 4C. Alright, so this was the combinations which we are writing. So now how can we optimize this? Alright, so there is a formula and there is a property of this combination. The property is, if I have NCR, and if I multiply a factor inside that, so we get NCR plus 1. Very simple. Alright, if I have NCR and if I multiply a factor inside it, alright, a factor inside it, we get NCR plus 1. Alright, very simple. So NCR is which when multiplied by a factor we get NCR plus 1, which means if I have 1C0, I can create 1C1. If I have 2C0, I can create 2C1. If I have 2C1, I can create 2C2. If I have 2C2, I can create 2C3. Either we don't have to create here. If I have 3C0, we can create 3C1. We can create 3C2. We can create 3C3. Alright, so by this method, it is the fast method or it is the optimized method by which we can search it down. Alright, so I hope you understood till now. So now, what is the factor? Now, the major question is what is the factor? So we'll find out what is the factor now. So I will write my formula again here. NCR multiplied by factor is equals to NCR plus 1. And I will not tell you the final answer for factor. We can define it or we can derive it very simply. NCR is n factorial upon r factorial into n minus r factorial multiplied by factor. I do not know what is factor. We will write factor only. And for NCR plus 1, so I will write n factorial upon r plus 1 factorial and n minus r plus 1. Alright, n minus r plus 1 factorial. So this is the derivation process, step 1. So we will cut this n factorial by this n factorial, and what we are left with, factor is equals to r factorial upon n minus r factorial divided by r plus 1 factorial and n minus r plus 1 factorial. Alright, so now how can we solve this? We can solve it down by, if I write r factorial and n minus r, we can open this n minus r factorial, write n minus r minus 1 factorial, and below we can write, we can open this r plus 1 factorial. So r plus 1 is opened and r plus 1 factorial, next term is r plus minus 1, r plus 1 minus 1, so r plus 1 minus 1 is r factorial and n minus r minus 1. How we opened this bracket, so this became n minus r minus 1 factorial. So can I delete this n minus r minus 1 factorial with this? Yes. We can I delete r factorial by r factorial? Yes. So I am left with only factor is equals to n minus r upon r plus 1. So this is our final output for factor. Alright, so we have understood how we can find out factor, and now what we have to do, what we can do, we can place this formula inside our question, and if I have, let's cut this out. Alright, so if I have this factor inside this question, is inside this pattern, so what we can do, we have NCR, we can multiply it by n minus r upon r plus 1, and we can get the value of NCR plus 1. Alright, so it will help us in getting the further values. Alright, so I hope you understood this till now. So we will now code it down and then we will see if it works or not. So we will go to Nado's website, and we are given with a function Pascal row, which has the return type of array list integer, and inside this we have passed a integer r. So this r is the row for which we have to return the values. All right. So firstly, what I have to return array list. So I will create an array list, because if you have to return it, you have to also create it first. And let me take it as list, small list, new array list. All right. And we knew that nc0 is 1 and ncn is also 1. All right. We have written this here. All right. So what we knew, that nc0 is also 1 and ncn is also 1. And when we knew that the starting index, which is nc0, is always 1, so can I start it with 1 itself? I knew that, because nc0 of any number, if I take any number with c0 combination 0, it will give me answer 1 only. So I will start this from int val 1. I will initialize it from 1 itself, because I don't want that it takes some time to calculate nc0 first. All right. So I will give my initialization by 1 only, and I will talk about further for the elements. So now I will place a for loop at columns. All right, because we have the row r, which is given by the user. Now we have to traverse at columns and create our answer. So I will write c is equals to 0. C will work till r and c is incremented. All right. Inside this, firstly I will add my 1. So I will add my value. Then I will create my answer by multiplying factor inside this. So I will multiply my factor. What is factor? No, nothing is factor. What we have to do? The formula was n minus r upon r plus 1. All right. So n minus c. Oh, sorry. R minus c upon c plus 1. All right. So r minus c upon c plus 1, when it is multiplied by our old value, we get the new value. All right, we get the new ncr plus 1. So this was the code itself, and now we have to return this array list in our main function, so that it will print it. So let's run this code and see if it works or not. So yes, it is successfully compiled. So we'll submit this code and see how many test cases are passed. So all test cases are passed. That means it is correct code, and we have written it correctly. So our logic is also correct. So I hope you understood this video. And if you understood this video, please like the video and share the video with your friends. And we'll meet in the next video. Till then, thank you so much.